Well, hello everyone. Well, we have something exciting today, announcing a new product, Wolfram Notebook Assistant. So let me tell you kind of the backstory here. So at beginning of last year, when ChatGPT came on the scene, everybody was surprised. We were too, but we very rapidly started understanding how this new neural net AI technology fitted in with what we had spent the last 4 decades building. And we realized that there was this amazing complementarity between the computation and knowledge technology stack that we built and this kind of linguistic user interface provided by ChatGPT and large language model technology in general. So within just a couple of months, we had introduced our chat notebook mechanism for accessing LLMs from within Wolfram notebooks. And I had made an analysis of ChatGPT. I even wrote this little book, What is ChatGPT Doing?, which also is posted on the web. And now, eventually, look at this. There are all these different versions of the book in different languages that exist. Who knows which of them? Some of them have more, all sorts of things here. There's one with an interesting cover. But in any case, we were been quite involved in trying to understand what becomes possible now that neural nets and LLMs can do the things that we now know that they can do. And in fact, I've been involved quite a lot in the science of LLMs, in understanding most recently sort of the foundations of what's really going on in machine learning. To what extent can LLMs kind of solve problems in science, these types of things. But all that time, since the beginning of last year, we've also been working on something else, which is building something very practical, something that I think is very useful, which is what is now our Wolfram Notebook Assistant. So the idea of Notebook Assistant is it's something you just talk to it linguistically, you tell it what you want to do, just say it however you think of saying it. The Notebook Assistant is really good at taking things that you have only formulated in a very vague way and crisping them up to the point where they can be made computational and actually implemented in Wolfram language. And I have to say, I thought, I'm a pretty expert user of Wolfram language. I thought this is not going to be terribly useful to me. I was wrong. It's very useful to me. I have it up all the time these days. It really makes me both much more efficient, and it also makes me bolder in the kinds of things that I do. I'm like, well, I just wonder if something like this is possible. I can't quite think through how I would do that. I type it into Notebook Assistant. It will come up with some idea for what to do. Often, sometimes it actually nails it immediately. Sometimes it just goes in roughly the right direction, but it helps me to be bolder in the things that I'm trying to do. For people who don't know Wolfram language or don't know it well, people who have not really even dug into computational thinking, I think Notebook Assistant is really quite transformational because it lets one go from the things one's thinking vaguely about to things that are actually implementable in a computational way. And I have to say that what's possible leveraging Wolfram language now with Notebook Assistant is really rather spectacular. I mean, it's with LLMs on their own, you get this kind of linguistic interface. You get a certain amount of kind of, well, what would you say next type thing. But what's happened here is that we've taken all the work we've done with Wolfram language and this whole computational language that we've built, this whole way of kind of expressing oneself computationally, and that turns out to be this sort of perfect match with what one can now add this linguistic interface to. There are many aspects of Wolfram language which are sort of critical in this. The kind of systematic nature of the language makes it possible for the LLM to guess correctly what to say. The fact that the language is symbolic, which means that any little fragment of language is already meaningful, that's critical because it means that the LLM can just produce that fragment, show it to you. That's already something useful that you can actually put in. It's not something where there needs to be lots of boilerplate around it to get it to even be connectable to anything. Another thing that's really critical is the fact that Wolfram language is intended as a kind of general representation of computational ideas, as a kind of concretization, notation for computational thinking. same kind of way that mathematical notation is a notation for mathematical thinking. And that means that when the LLM produces, when the notebook assistant produces a piece of Wolfram language code, it's something that we humans can read. It's something where, in a sense, the Wolfram language code is the succinct definition of what it is that that one wants to do. It's like you can have a kind of linguistic discussion on one side, but if you really want to know what is the notebook assistant thinking, the answer is it's the piece of Wolfram language code it produced, which we can then use. So, okay, well, so how do you use this? Well, let's see. We can, let me start showing you something here. So if you have version 14.1 of Wolfram language, that's the latest version, then as of today, tomorrow, the next day, it will auto-update itself so that you'll be able to do exactly the things that I'm showing you. You have to sign up for a subscription to Notebook Assistant. It's a separate product, but you can do that easily through the portal. But what you will already find in version 14.1 is the toolbar at the top has this little button here that's a little indication that it says assistance at the top, and then it's a little button you press, and up will come on the side of the screen the Notebook Assistant. So, for example, we can say, now we can start asking it things. We can say, I don't know, how would I find the running max minimum in a list? And now it'll go and think for a little bit, and let's see what it does. Now, one thing I should say, I've been demoing computer systems for nearly half a century. And the one thing that's really difficult about demoing systems that involve LLMs is you really have no idea what's going to happen. I'm used to the idea that at least I understand the computational representation of what I'm feeding into the computer. And even though I don't necessarily know what the computational answer will be, I do know sort of I do have a way to think about what's going on inside. With LLMs, I don't have that. And it's a thing that I view it as being a little bit like doing a presentation where you have a wild animal on stage with you, and you've tried to wrangle it as best you can, but you can't be absolutely sure what's going to happen. That's what happens whenever one's using LLMs. But anyway, let's see what this did. So how would I find the running maximum minimum in a list? Okay, so it says you can use the fold list function. Okay, that's a good start. And now it has an actual piece of code here. And conveniently, it's given me an example, which is nice. I can then just insert and evaluate. I'm running that example. I see the result. And it has a little explanation of what's going on here. By the way, we can always say, generate a new version. If we didn't like the version that it produced, we can always press this regenerate button, and it will generate another version. Maybe it'll say exactly the same thing this time. Maybe it'll say something slightly different. Okay, all right. So here it defines a function for running minimum in this case. It's made a slightly different choice of how to answer my question. All right. So if we're sort of changing topics, we can always press the new chat button up in this corner. It says, ask me anything. So let's try something else here. Let's say I put an image here. This is, these are the cats of the person who edits my, the posts that I make. So now we can ask something like, how can I find the cats in that picture? And it'll now refer to, I hope, the notebook that it can see, and it might be able to, let's take a look, see what it did here. So that's interesting. Okay, so it said use image cases, and let's see. I have to make this a bit bigger. It says use image cases, and then there's a picture, and then there's with the word cat. Let's see what happens. Let's see. Oh, to return a list of sub-images containing cats in the image if you want to get the positions of bounding boxes, blah, blah, blah. All right, let's try actually running this. Let's say insert and evaluate. Let's see what it does. Okay, it ran it. Oh, no cats. You know, this is a rather low resolution of this picture, low resolution version of this picture. So it may be not easy to find the cats. Well, let's see if we can say, let's ask it a different thing. Find where there's yellow in the picture. I have no idea what this is going to do, but let's see what it does. See whether it can give me something useful here. Aha, okay. So it says pixel value positions. All right. I didn't even know that function. Let me just see whether let's see whether that does something useful or whether it just made it up. The number of image channels does not. Okay, so it didn't know that this was a four color image. Let's see what this does. Okay, let me see what it does. That okay, so it still is not very successful here. I wonder whether it has some. This will return the positions of pixels that match the specified yellow color. Okay, well, within a certain tolerance, within tolerance 0.1. Okay, well, let's see. We say tolerance 0.3 here. Let's see if we can. Okay, that didn't work. Let's see what it says. And see whether it, okay. Asking, oh, now it's correlating with yellow. Actually, you know what? I think I said 0 here. I probably should have said 1. Okay, there we go. Now we've got a bunch of results there. Let's say we say here, let's say uh, show those pixels in the image, see whether it has any chance of doing it. And as I say, I'm going. This is a completely this is a wild animal show type thing. Okay. Now it's trying to do something here. All right, it's actually trying to compute something. And it's detecting the whole elaborate thing it's doing. I'm not sure it's doing the right thing, but anyway, it's trying to do that. Maybe let's start something new here. Let's try something. Let's try something a bit more straightforward. Let's say we want to ask it. Let's ask it some question. I think I had this in my post today. You can ask it something like, it's a little narrower so we can see both at the same time. It's very useful to have this notebook assistant window off on the side here. So let's say, how can I make a 3D plot of the terrain around a volcano? See what it does to that. And notice it's pretty vague what I'm asking. It's so it's going to have to figure out. Okay, so it's gonna have to pick a volcano, but pick Mount St. Helens. It's gonna have to pick what it means to say around. It's picking 10 kilometers. Let's see what it does here. Let's insert this and evaluate and see whether it actually has produced something. And now it's having to think a bit. It's probably reading in some. There we go. Oh, look at that. That's cool. So there it managed to, so it's put together a bunch of different things. It's decided which volcano to show. Then it's got all this stuff about listplot 3D, and it's produced a piece of code. Now let's see. That chopped the top off. How do I show it? Very vague. Let's see if it understands what on earth I'm talking about here. It may not. The some let's see. Probably trying to read in that picture and look at the picture. Taking it. Okay. Let's see what it's going to do next. Okay. Very good. Very good. Look at that. Plot range all. That's the right thing to do. And then it will show it correctly. Actually, I probably could say, now I know what to do. I could just say, show that with plot range all, and it probably will. Oh no, why didn't it do it? It must have, what did I do? Oh, it's too late. I should have done it in the list plot 3D. I should have listened to what it said, because it told me exactly the right thing to do. All right, another example. So let's see. We can try. Here's one that was a real thing that came up for me a couple of weeks ago, which was how do I swap the nodes and edges of a graph? So it's pretty vague, and I couldn't just search the documentation for that because it's not really, it's I think I should put it out of its misery and delete these big pictures here because it's trying to read those in, because it tries to read the context of what's happening in the notebook. You know what? I think I should have asked that question separately rather than having it be part of the. Well, let's see. It may get confused because I was still talking about mountains and volcanoes and who knows what else. Let's try it. Take a look at what this does. So what is this? I don't think that's what I wanted. This is just saying how to reverse a graph. So let's try that again. Let's just say regenerate that. I think what I want to do here is let's just do a new chat here. Save myself typing by just copying that and do that. Let's see what it's doing. It's still thinking about that a bit. And, okay. Well, maybe this is a reasonable way to do it. How do I swap the nodes and edges of a graph? So define the original graph. All right, let's see what this actually does. Let's copy that. Let's paste it in here. Maybe I want those separate cells. And let's say, well, here's our original graph. And now here's the reversed graph. And what's this going to be? This is saying create vertex replacement rules. Not sure why that's the relevant thing. Let's just say, is there a way to make a dual graph where nodes, where vertices and edges are exchanged? Try that, see if that helps it to understand what's going on. Okay, so this is now making a dual planar graph. That's a reasonable thing to do. So let's try inserting and see what the original graph was here. Okay, so that was that did something reasonable here. That wasn't quite what I was looking for, but that's getting me in the right direction here. And so it says dual planar graph creates a dual graph where the graph's faces are converted to edges, blah blah blah. So it did something reasonable based on what I was asking there. So let's say I want to do something like let's give it something a little bit more open-ended. Let's say how can I compare two different histograms? And let's see what it does. See whether it gives me a kind of a useful analysis of that. Okay. Okay, so let's see. We can compare two different histograms using a variety of methods. such as creating paired histograms. Here are some examples. So let's try that. Let's see whether it does that, whether we think that's useful. Let's try insert and evaluate that. So again, that's pretty nice. It reasonably figured out here are two different sample histograms to use. Then it made this paired histogram here. What did it do here? Using different layouts. What's this now? Let's try this one here. Okay. The overlapped version and the stacked version of these histograms. That's reasonable enough. What about paired smooth histogram? Okay, I didn't necessarily know there was a paired smooth histogram. Let's see if it's do that. Oh, look at that. I didn't even know that existed. So, okay, so that's now showing, that's pretty nice actually. That's showing the smooth distributions compared here. So again, something that already just happened here is, I know Wolfram language pretty well, I think, but I didn't immediately know that there was a paired smooth histogram, and it surfaced that for me in a way that was useful for the question that I asked. So, one of the things that happens is you tell it to do something, and it will interpret it in its way. So here's an example. How do I make a picture of a circle with little circles, little red circles, red disks around it? That's pretty vague. Let's see what it manages to come up with for that. And what we'll see here is that that's kind of the first thing I think of, and let me see what it does. So let's see what that did. So let's actually that's pretty good. That's pretty much what I would have expected. But let's say how about that's a pretty reasonable thing, and they're pretty reasonable size. How about having more circles but more, well, maybe let's try just more circles but smaller. It may get confused there because who knows whether it knows whether the circle's disk's the same thing. We'll see what it's going to do. But again, this was a pretty reasonable thing. If I want to get a first cut of that, you create multiple circles. Here's an example. Okay, let's try. Oh, okay, well. All right, let's see. Come on. Here we go. Aha. Well, that's amusing. How about having more circles but smaller? Well, that's a pretty reasonable interpretation. It's not what it's not what I had in mind, but I was pretty sloppy in what I said. But what it did was pretty reasonable. Now, let's say I want to adjust this and I want to say, let me make purple disks instead, and let me make them actually circles instead of disks there. Well, I just go in and I edit because this code is pretty easy to understand. I can just go in and edit it myself, and that's a pretty good mechanism. The notebook assistant kind of gets me started, and then I can go and edit the thing myself. Okay, well, so let's try something more ambitious. Let me say, this is an example. How do I make a published web form that makes 3D images of molecules? See what it does with that. So, when we were building Notebook Assistant, I didn't really know how useful it was going to be. It's hard. This is the kind of thing where, okay, let's take a look, see what this actually does. All right, let's just try copying that, and let's try evaluating pieces of it. All right, let's take a look here. This is asking for, so it's making a form function that is going to look like this. Enter a smile string to view the 3D structure of a molecule. Okay. All right, let's try this. So now it says publish the form, and let's go ahead and do that. Oops. Okay. And now we've got that form published to the web. Let's go there and let's see what it did. Enter a smile string. Okay, well, I don't actually remember those very well, but let's try something like this. And it's about my level of smiles knowledge. Oh, that's unfortunate. Okay, so it had a bug there where it had molecule arrow. Huh, that's very odd. Why did it do that? Actually, that looks correct to me. What happened here? Molecule plot 3D. It's hard for me to ask it what went wrong here because it won't be able to see the actual deployed web page. I have to say, I would have expected that to work. Title, description, molecule plot 3D of the molecule of the string. Oh, I know what went wrong. Hey, that's a pretty tricky mistake. That should say hash molecule there. That's a tricky mistake. All right, let's try that again. And let's try that. Try my little thing again. Oh, you can have brackets. Just try that. And running. Ah, look at that. One molecule, even rotatable. So that's pretty nice. I mean, okay, I had to help it a little bit, but it's still pretty nice that you can just say this very vague thing and it will start producing results. So now, let's see, publishing. This form is deployed to the cloud, so it's giving you a better explanation here. Honestly, I don't find myself reading the explanation unless something goes wrong. And otherwise, I just use its code. I read its code, which, because it's easy to read Wolfram language code, and it's pretty good Wolfram language code usually, it's a good way to kind of engage with what's going on. Make sure you have a Wolfram Cloud account to deploy the form publicly. Okay, well, that's nice of it to say. Let's see. It says here that it's using the AR publish function, but actually it's not. So let's ask it. What about publishing for AR? Oh, let's say for a Vision Pro, so that it has a hope of dealing with that. Let's see what happens. This could go horribly wrong. And still thinking there. Okay, to publish 3D molecule visualizations for Apple Vision Pro, you can use the publish function. Okay. Oh, there we go. Look at that. AR publish molecule plot 3D. That's right. Okay, so it's going to actually return the AR. It's going to return probably a barcode that you can then use with the Vision Pro to get it probably explains it here. Okay, well, I think it's going to produce a barcode that you can then use with the Vision Pro to get the thing deployed for augmented reality. So, to me, this is very useful because I don't now have to go and try and figure out, oh, what does AR publish? How does that work? It's given me a way to do it. It's made up a good example of it, etc. Okay, so let's go on. Let's ask some. Sometimes you might just want a sort of a finished goods thing. How about, let's say, make me an image of, let's say, the isomers of, let's say, heptane. Let's see whether it can do that. Let's see whether it will. So it will be both able to do things directly in the Notebook Assistant window and giving you code that you can then run. So let's see what this does. This all right. So in this case, it's giving me, telling me you go run this. Let's see what happens if I do that. That's really nice. There we go. There's a picture. I can say, let's try and make them 3D. So it does that. Okay. Well, it looks like I can already see that that's going to work, but I could run it just for fun here. There they go. Um, and actually, let's ask it a little bit more. Put boxes around those and label them with their smile strings. Don't know if this is going to work, but let's see. I mean, I'm asking it to do, not sure if I would know how to do that, but let's see what it does. Okay, it's actually running Wolfram Language Evaluator here. Let's see what it does. Aha. Okay, so it had a guess for how, let's try this again. Okay, so it tried it once and it made, oh, wow, look at that. Well, I'm impressed. So it figured out the plot label should be molecule value of the thing with hash sign. I don't know why it added plot range padding. It didn't put the boxes around, but it did. It did really well here. I'm impressed. Okay, so let's try something else. I mean, let's say we say something where we might have let's make a new chat here. Let's say plot the number of transactions in the last 10 ETH blocks. Let's see if it can figure out what to do here. Again, remember this is wild animal wrangling, so I have really no idea whether it will succeed in figuring out. So again, it's trying to do it itself there, rather than just giving me code to, because I didn't say how can I plot the number of whatever. I'm asking, okay, let's see what it's doing here. So one thing it's doing internally is it's making extensive use of documentation and lots of things that we built based on that to be able to actually know what to do here. This is not sort of a pure LLM. It's a heavily kind of harnessed. Wow, wow. Well, I'm impressed. That's okay. Let me just, just so I know, because I'm a little bit scared. Let me say that. Uh, I mean, it looks like it did the right thing, but let's just see. Okay, so this is saying I get the last 10 blocks, blockchain block data. Okay, last 10 blocks. Oh, that's interesting. It did it in that. Okay, that's right. It did it in the order from further longest to go block to the most recent block. So I wouldn't have necessarily known that if I hadn't actually read the Wolfram language code. Total transactions, blockchain base is Ethereum, and now it's plotting those in this way. So actually, let's say, I don't know, make that a bar chart. Say, see whether it can do that. But again, one of the things it does is it has no fear of busy work. So if I was doing this, I'd just make the plot, and I wouldn't see if we run this, what it will do. And I wouldn't bother to put in plot labels and axes labels and all those kinds of things, but it doesn't mind doing that busy work, and it does that. So it's probably taking a little while to retrieve all this data. There we go. Lovely. Okay, that's a little funky. Block index -10. Well, not an unreasonable thing for it to do, and it's clear what's happening, and it's clear that that's the longest to go block and so on. Okay, well, it's uh, what's really nice is how encyclopedic its knowledge of Wolfram language is. So any corner you can expect to get. So if I say make a multiplication table for S4. Let's see what it manages to do for that. And I could have given it a little bit more. I could have helped it. Okay, but it figured out that probably I'm talking about the symmetric group S4, and let's see what it did here, see whether it can do it. Let's see it. Let's insert that. Let's see whether it, wow, look at that. So I would have had, let's say, plot that. And now it'll probably produce, I wonder what this looks like. Okay, let's see. So evaluate that. Okay, that's cool looking. But in any case, the thing again is that we are it's kind of diving into a corner of Wolfram language, its group theory capabilities, and it's able to get that result. Okay, well, what if you really have no idea how to start? There was an example a few weeks ago. We were talking about this. I was talking to the person who heads North American sales for us, and I said, it's really going to be able to do anything. So I said, how about we ask it, how would I design incentive curves for a sales group? Let's see whether it manages to produce anything reasonable. Because the question here is, can I make that question computational at all? Where do I even start? And let's take a look. Well, it's going to give me a bunch of random stuff. Okay. Okay, here's an example of how you might, okay, so it's giving me a bunch of blurbs about sales incentives. What on earth is that? Let's take a look. I don't even know what a funnel chart is. Okay, that's not so impressive. Let's just regenerate this. Let's see what it does. Ask it to just try again. I suppose that's indicating, okay, it's accurating. Okay, let's see what this is doing. Here's an example of how you might visualize different incentive curves using them. Let's see what it did there. Okay, that's more interesting. All right, so it's giving one a stepwise set of incentives, and exponential, linear, et cetera, et cetera, et cetera. How about I say something like make that interactive. That's what it does. Now, remember, this is not going to be the answer. It's not going to be, what you want to deploy. But the thing that's important is it's a start. It's a way to get some idea to go from, I have no idea how to make that computational, to something where, let's take a look. Okay, so it's not too exciting what it's doing here, but it's giving us some idea of what might happen. So, I think this is the important thing here is, even if you don't know if you don't know how to start making something computational, this gives you a way to start. So, for example, let's say, let's try something like, let's try, I don't know. We could try many different things, but maybe what we'll do in a few moments, we'll kind of open this up for questions, so people can be thinking about things they might like to get me to try. As where do we start from in making something computational? So already I've shown you a bunch of examples where it's very useful to be able to have Notebook Assistant tweak things for one. Let's say I make a plot of a sine curve. Okay, so it's going to make kind of probably an unembellished plot. I could have typed this in myself. Maybe I should have typed it in myself. It would have been faster in this particular case. I just type that in myself. Oh boy, it's got all kinds of labeling it's doing. Let's evaluate that. Okay. Okay. Mark the maxima. Fill the curve. Make it red. Put a box around. See what it does. Try this now. Not bad. Okay, there's only one maximum. So, okay, it pretty much did exactly what I asked. Okay, make the plot over 3 times the range. Yeah, man, what to do. So try that now. Very nice. Okay. So again, this was a piece of sort of tweaking that I was able to do, where it's a bunch of fiddly work here, of figuring out how you put the epilogue on it to make points, et cetera, et cetera, et cetera. And this is again something I find really useful is this kind of busy work that it's able to automatically do for one. Okay, let's try something else here. Let's try something where you write a piece of code and it doesn't work. So let's say I say reverse hello, it's going to complain, and then I can say to the notebook assistant, what went wrong? Question mark. And it's going to be looking at that notebook, and actually you can see that it's looking at that particular notebook because it says down here focus notebook, that particular file. Okay, so it says it looks like there was an error with the code reverse of hello, the message blah 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 indicates the reverse expects a list or other compound expression to reverse, but it received a string instead. To reverse a string, you can try using the string reverse function. Here's how you would do that. So that's pretty useful. Now, if it's in the middle of a big piece of code that I wrote, then and something went wrong, it has a big advantage because it's able to read a bunch of internal telemetry that's coming from inside the Wolfram language evaluator. It's reading things that, as a human, one can get access to, but it's really voluminous, and one isn't in practice going to read through it. It takes a lot of effort to read through it, but the notebook assistant can kind of read through that and figure out what's going wrong. And it's actually surprisingly, in my experience, as practically writing somewhat complicated code, when things go wrong, it has surprisingly useful things to say. It doesn't always quite nail what's happening, but it gets me started. It gets me looking in the right direction. Well, you can also do things where you just say, if you write a piece of code, let's write a really horrifying piece of code. Let's say for I equals 0, let's say we're writing like Fortran or something. I less than 10, no, it's a C rather. I plus plus, and then let's say append to a list I squared. And that's a piece of code that's pretty lousy. Let me select that. And let's say, let's start a new chat here. Let's say something like improve that code. Let's see what it will do. Hopefully it can see the right piece of code there. I could have selected it, actually. I just selected the cell. Maybe I should have. Okay. The given code uses a procedural approach with a for loop and append to generate a list of squares. A more idiomatic way is to use functional constructs like table, which simplifies the code and avoids unnecessary global variables. I don't think I could have said that better myself. And oh, look at that, it got it right. I said I less than 10, and it said it indeed gave the correct table. So, I mean, this is a very trivial example, but there are examples where sometimes I've asked it, how would I make that piece of code faster? And it succeeds in doing that. Another thing that that you can do is ask it to refactor code. So for example, let us ask it to write some code itself. Let's say, make a picture of a sphere out of little cubes. It manages to do that. So this is going to take it a few different steps, I think, to do this. I don't exactly know how I would do this. I would probably make a, well, let's see what it does. Oh, that was clever of it. That was clever. Let's see if this works. Not totally confident here, but let's try it. Wow. Look at that. Okay. Well, this was such simple code. It's hard for me to do what I was planning with it. Look at that. Select this. Okay, you know what? Make a, I'm just going to make this really difficult. Make a dodecahedron out of little icosahedra. I'm really making this hard, and this may not be able to do this, but we'll see what it does. That was a good solution that it gave there. All right, let's see what happens. First question is, did it manage to do it right? I wouldn't have done it exactly that way. I would have used the nice modern polyhedral functionality. Bah, not good. Didn't work. Okay. Well, let's first of all, let's just try again. So we hit the refresh button here. Oh, wow. It's discovered it did the wrong thing there. Let's see what happens. It's very insistent on using that. Oh, wait a minute. It knows about icosahedron. Well, let's try this. I'm not optimistic this is going to work, but let's just try it. My gosh. Wow. It did work. Well, let's just to tempt fate. I don't know how to delete something. That's a little bit of a UX issue. I don't know how to delete. Let's say use smaller. I'm really impressed here. Use smaller icosahedra so that it can make a higher resolution version. I think what it's doing there, it's trying internally to do this, and it's discovering it doesn't work, and then it's let's see. Let's try that again. Ooh, that's shocking. Well, okay, let's just ask it what went wrong. So it managed to do it very beautifully, very impressively here. And then it's interesting what it did. Look at what it did. That's quite clever. It took the icosahedron and it just transformed that around to all the places it needs to go to get it at the vertices of the other thing. Okay, here's what went wrong in the code. Incorrect property, the property mesh, blah, blah, blah. Using polyhedron data for blah, blah, blah. Okay, let's just see if it managed to correct itself. Nope, it did not. Okay, well, we're probably going to have to help it, but it already, I think it gets a lot of points for having succeeded up here in producing that result. That was very impressive. Other things to kind of know about. Another thing is just the explain it to me. Tell me about, let's see, I think I have a little piece of code here. Let me just do that. If I type in a little piece of code here, I had something which is something that I wrote. Point list of max 0 ceiling 2 comma hash. And yes, I do know how to write code in this language, so it's but this is something that I wrote by hand, so to speak. Let me just see what this is doing there. Oops. It says I know how to do this. Oh, that's what's wrong. It needs to say log. That, total of that. Okay, so this is a piece of code. And I can say explain that code. I mean, again, I can read it myself. myself confused there with that polyhedron data stuff. Okay, so let's see what it says here. It says, let's go through the code step by step. So log 2 comma hash. This computes the base 2 log of a number. In this context, it's applied to each number iteratively. Okay, the ceiling function rounds up, blah, blah, blah. Fixed point list. In summary, the code computes the fixed point iteration, taking the ceiling of the base 2 logarithm and returns the sum of all the values. Well, that's kind of saying it in English. Personally, I prefer the Wolfram language code here as the explanation of that. But this is, I could probably, let me just try this. Try this. Oops. Oh, dear. Okay. Start this again. Okay. Just start this. Okay, there we go. So anyway, explaining code is a useful thing. Another thing that's really useful is if you're making something like a function repository entry, you can have it, again, sort of do the paperwork for you, fill out some examples, write some tests, the kinds of things where you say, yes, I can write the core function quite quickly, but then filling in all that paperwork is lots of effort. Well, this can do that for you. Okay. Another thing that that's there is, yes, the toolbar doesn't magnify, but if you can see it, there's this light bulb button that we're calling the inspiration button. And so what it does is if you press the inspiration button, it will do something in the context of the thing that you've typed in. So for example, I left the cursor right after plot in sin X, and it says it's generating suggestions. Okay, now it's suggesting I might continue that with comma x0 to 2 pi. And it got the brackets a little messed up, but there it is. So that's a way that you can do things like that. You could say something like, it's a way of kind of making a much more elaborate form of auto-suggest. It's something which exists for other languages. I think it's much more sophisticated here, but it's not the same as kind of the conversational thing that you can have with the side chat with the notebook assistant. But for example, if you select a piece of code, it can simplify it, those kinds of things. Now, things get more exciting with the inspiration button. If you just write something like you say, I don't know, plot a plot of an irregular Bessel function. And I type that in and I put a colon there, and then I go to a new cell and I just say, use some inspiration. See what you can generate as the next cell. So let's see what it does. It was just given a piece of English language text. Okay, so now it suggests plot Bessel Y1, whatever it is. We can fill that in as the next cell, and there it is. It sort of magically wrote code based on the comment that I gave. So now let's say properties of the irregular Bessel functions. Actually, I'm just going to ask it for inspiration right there. Properties of the irregular Bessel. Okay, functions. Good suggestion. Except it could have had a space there. Now I go there, and now let's ask it for inspiration. What to do next? Let's see what it generates. Okay, that's crazy because it's just basically kind of writing my essay for me. Irregular Bessel functions have a number of interesting properties, it says, in a rather LLM-like way. Unlike the regular Bessel functions, blah, blah, blah. Okay, so it's now showing me some property there. and too exciting a property, actually. That's all Y function. Okay, well, that's fine, but it's not, I'm not so impressed with that particular thing. Let's try this. Okay, that's a nice picture. But in any case, the idea is that you can start off and just ask it, give it a direction, and ask it to just start filling things in from there. And again, that's pretty useful if you're writing tests for something or something like that. Let's see. Well, practicalities of using the Notebook Assistant. I should explain sort of the main thing that's going on here is you've got this kind of side chat. It's referring to the notebook that you're working on. And that's pretty useful because you don't kind of want to muddy up typically the notebook you're working on with the things that you're talking to the assistant about. So that happens in the side chat. You can always look at the history of your chats, and we could go back and we could pull back up the chat that we had. I hope we could pull back up the chat we had about isomers and so on. And we could also do this. We can pop out the chat as a separate chat notebook, and this is now. So now we're seeing this thing as a sort of a sequential transaction where we're using the LLM evaluator to figure out what to generate next. So we're doing a chat in this way as a chat notebook. Actually, coming in the next version, chat notebooks will be a standard part of all notebooks. And so you'll be able to, if you have the Notebook Assistant subscription, you'll be able to just type a quote and get a chat cell in any notebook. In version 14.1, you can do that by making a specific chat notebook that is all chat, so to speak. In any case, the thing that we've got here is in the Notebook Assistant, we've got whenever you are sort of talking to the Notebook Assistant, you can give it a focus at what it's looking at. So here it's the Notebook Assistant window. Notebook Assistant notebook here is what it's focusing on, and you can just get a list of possible sources. Coming soon, the list of sources will also include files and so on that you can have it refer to. So that's kind of the big story here. Along with Notebook Assistant comes bundled LLM Kit. LLM Kit is kind of the low-level interaction, supports kind of the low-level interaction with LLMs. In particular, it's using our LLM infrastructure, our system for accessing LLMs. That's not yet our own LLM. I have to wait for that. But we're using our own system for accessing LLMs. So it's kind of a hassle-free way to get to LLMs. And you can use that both for Notebook Assistant, it's the infrastructure for Notebook Assistant, and you can use it for programmatic access, things like LLM function, LLM synthesize, all those kinds of things. You can see all of this if you go to the Preferences panel here, I hope, Preferences, and you go to AI settings. You will see now that the default LLM, that what we're accessing here is Notebook Assistant plus LLM Kit. We still have access in principle. You can have access not with Notebook Assistant, but with the LLM Kit, you can still have access to any other kind of LLM that we support, but that's not going through our LLM infrastructure. That's just going raw to those other services. For the Notebook Assistant, you're going through our LLM infrastructure. For LLM Kit, in general, you're going through our LLM infrastructure to use LLM functions. So what does this all mean? Well, I think as I say, for somebody like me, who's, I think, a pretty good Wolfram language programmer, I had thought, I'm not going to need this. But I was wrong. It's something that it's super useful thing to have up all the time, the notebook assistant. And every so often I go ask it something. Sometimes that's asking it a detail that I want it to fill in from things I'm already doing. Sometimes that's, I don't really know what to do next, and I have some vague idea. I give it my vague idea, and it's kind of a good sounding board for vague ideas, because it's really good at turning kind of vague ideas into definite computational ideas implemented in Wolfram language. So I find that really useful. It allows me to be both sort of a little lazier and a little bolder in the things that I do, because I can just say, well, I just wonder if you can do this. And it'll go off and say, yes, there's a way to do that. You know, for me, the whole thing in using tools, computational tools, is how do I get the barrier low enough that I can do things kind of on a whim? A lot of the science that I've done is a consequence of the fact that it was easy enough for me to do computer experiments that I actually tried to do them, even though I wasn't sure what the result will be or how valuable it will be. But to be able to sort of do things on a whim is very important. And what Notebook Assistant does is it reduces, again, the level of what you can kind of do on a whim. You can just say, I wonder whether something like this is going to work. Well, let me ask the Notebook Assistant and see whether it's going to work. And then you're sort of off and running potentially in a particular direction. Well, it's kind of giving one, crispening up. It's doing something that's really surprising as possible. That is, it's taking sort of vague human thoughts and crispening them up to the point where you can make them computational. To some extent, we've done that with Wolfram Alpha. From 15 years ago, we've been able to take specific things that you're asking and turn them into Wolfram language. This is a much more general, vaguer version of the same kind of thing, except here, we're not just giving you the answer as we do in Wolfram Alpha, we're giving you kind of the tools to do things yourself, and you're expected to be able to read the Wolfram language code. It's not, it's a different branch of things from the Wolfram Alpha branch. It's really a branch that I think is critical for sort of building computational X, for all fields X, kind of the computational version of that field. And I suppose another aspect of what's going on is this is something that's very useful to anybody who uses Wolfram language, from experts to people who are just starting. But beyond that, it's useful for people who want to do computational thinking but don't really know how to do it yet. Because all it requires is that you vaguely say what you want, and it's responsible for crispening that up to the point where it can be made computational. And so for me, it's something really exciting that we can provide the technology that we've been building for so long, and to a much broader range of people, where the kind of the notions of computational thinking are not things they necessarily are familiar with, and they're not familiar with the details of Wolfram language. But this is a way to kind of an on-ramp, a really impressive new on-ramp to get to computational thinking, get to computational language, get to Wolfram language. And it's something that, were it not for the fact that we have built Wolfram language as this full-scale computational language that's kind of a computational representation of the world, you wouldn't be able to get to this in any other way. It's like first spend the 40 years to build Wolfram language as it is today, then along come the LLMs, then there's this linguistic interface that one can set up. It's taken us nearly 2 years now to build from sort of the low level, yes, you can connect it to an LLM, to what we have now that I think is a quite refined way to access, kind of to make the best use of both LLM technology and computational language technology. But the thing that I think gets really exciting is it means that there's a vast range of people and things in the world that can kind of go computational where that hasn't been possible before. And I think if we look at the sort of the future of computational X for all X, I think the arrival of Notebook Assistant will actually be an important inflection point, being able to take people who are, I don't know, archaeologists or something, or who are people doing some field that hasn't traditionally been terribly computational, and now say, I just wonder whether there's a way to make this or that thing computational, just type it in and see what happens. And sometimes it might not be useful, but in my experience, more often than not, it's actually a good computational idea, a good computational direction to go in. So I think that's a really exciting thing that that Notebook Assistant will make possible. And when we were first building this, I thought of it as a practical utility, something that would be useful maybe for intermediate Wolfram language users who kind of knew a certain amount but needed a little bit of extra detail. I didn't imagine it would be as useful as it is to expert users. And I didn't imagine that it would be as strong as it is in going from just an idea to something computational that can be implemented. I titled the piece that I wrote today, "Useful to the Point of Being Revolutionary." And that's, I think, a good summary of what we've seen with Notebook Assistant. At first, it was intended to be something just useful, but it turns out it's so useful that it's actually something that I consider quite revolutionary. All right, well, I'm happy to try and address some questions, and let's see what we have here. Let's see. Sundus asks, how do you envision using this in your projects? Well, I've been using it for a while. It's been getting progressively better. We've been gradually polishing the UX and so on. The way I use it is kind of what I was saying. It's kind of an assistant. And when I run into trouble, I ask it, what's wrong? How do I fix it? And when I'm just sort of vaguely thinking about something, it's like I just, I don't even know. I have not properly formulated kind of a computational version of what I'm thinking about. It's kind of like give me a suggestion for what to do, but it gives me not just some vague suggestion written as an essay. It gives me a piece of Wolfram language code that I can try running and see what it does. And most of the time, as you could see, the Wolfram language code it writes is both correct in the sense that it does something. It may not do what you want. That's a different issue, but it does something. And it's actually also pretty well-written code. And that has the great feature that you can read it. And it's succinct. You can actually pick out the pieces. You can say, oh, this is an epilogue with a red point and so on. I'm looking at a screen here, which I'm not sharing, but you can expect to understand it. Why is this, Elsie asks, how does it compare to other things that work with notebooks? I think people, we invented this idea of notebooks back in 1987, and eventually 25 years later, people started copying it. So it's shocking that it took so long. But in any case, the kind of what we think of as a Wolfram notebook is a bit more sophisticated than what I think people have copied in the other notebooks of the world. I don't know. The important thing here is that we have Wolfram language as a target for what the LLM is talking about. It's without that target, without that computational representation of the world, it's a very different story. Without that target, if you're using kind of a standard low-level programming language, as opposed to the kind of our sort of full-scale computational language, if you're using a traditional programming languages don't talk about the world. Programming languages talk about the things going on inside a computer. And it's there's a certain amount you can do there. You can expect that there'll be blobs of code that get written to do anything you want. And maybe the code will be correct, maybe it won't be. It almost certainly will not be readable in any efficient way by a person. But the most important thing is that most of the examples I showed you today relied on the fact that Wolfram language has a representation of things in the world. If I say, make a picture of the 3D picture of the profile of a volcano or something, it knows about volcanoes. It knows about the volcanoes in the world. It knows about geo-elevation data. It knows about 3D graphics and so on. These are things that it can rely on because they're part of Wolfram language, because we have this computational way of talking about the world. That's what makes this really powerful. Which models is notebook assistant using under the hood by default. It's a complicated collection of models. It's using different things for, it does a lot of retrieval augmented generation. It does what we call computational augmented generation, being able to actually run things with tools and so on inside the LLM side of things. So we're using a variety of different models for embeddings, for actually generating LLM output, and it may change day to day what model it's actually using underneath. You can find you can get some idea of what's going on by going to our website. We have our LLM benchmarking project, which has a big list of LLMs and their performance on Wolfram language tasks, and that's a good guide to how we're figuring out what to use. Okay, Scott asks, good question, how is this different from chat notebooks? Chat notebooks are going much more raw to an external LLM model. So you can pick your favorite LLM vendor. We've built links to all of the major ones. And in a chat notebook, but in so far, up to version 14.1, in a chat notebook, you have to have made a connection to an external LLM provider, and then the chat cells that you write will be specifically sent raw to that external LLM provider. What we've done now, and that's what's taken so much time and work, is it's not just going raw to an LLM. There's all kinds of what gets sent to the LLM is a complicated, dynamically prompted thing that includes lots of semantic search on lots of different sources of things that we think will be relevant in what the LLM is trying to produce as an output, and then what comes back is processed in all kinds of ways. In addition, the actual sending of things, it's not going to a raw external LLM provider. It's going through our infrastructure to get the LLM to deal with the LLM, and the data isn't kind of leaving our ecosystem, so to speak, it's something where kind of we're taking care of all of that plumbing. In the upcoming version 14.2, chat capability, our kind of chat capability will be something that you can access by default in any notebook without having to go to an external provider. Let's see. Elsie is commenting, most of us don't dream and think in Wolfram language as I do. Yeah, well, it's actually I have to say, maybe I'm living in a bubble, but I know an awful lot of people who know Wolfram language well enough to be fluent in the sense that, as I find for myself, I can start typing before I could say what I'm intending to do. And that's kind of a fluency in the language. Fortunately, now with Notebook Assistant, you kind of have another partner in fluency, so to speak. All right, let's try. We've got some actual questions here for things to try. Let's give them a try. Go ahead and share again. All right, we have a question here from Kim. Can you make a bifurcation diagram of the onset of chaos? Let's just take this. I'm living very dangerously here, but let's see what happens. Make a bifurcation diagram to examine the onset of chaos in something like an RLC circuit. I don't think RLC circuits have chaos like that, but let's try. Differential equation, okay. Transformation to iterative map. I'm not convinced that that's what you should do. And then making a bifurcation diagram. All right, well, let's just, as I find myself doing way too often, it's just run the code, see what it does. Okay, that wasn't too exciting there. Let's see. See, I don't think there is chaos in a linear RLC circuit. I think you need some nonlinearity. So let's take a look here. Well, let's look at what it did. It has an ND solve. That's differential equation solving. It's got a driving force here, sine omega t. You know what I'm going to do? I am going to do something completely horrifying. I am going to say squared here. And let's see what that does. Aha. Well, look at that. See that data there? Well, you can barely see it because it's got lots of little tiny points. Let's make this a list line plot. See, I'm working with it here a little bit. It's okay. Now we've got chaos. Okay, and this is as a function of the driving amplitude. Wow, it went really crazy. It's going 10 to the 34, 10 to the 74, and so on. I did something completely crazy here. I took my let's see, what would this be? This is the if that's the capacitor, that's the resistor, that's the inductor, I think here. So this is, I took the resistor, and instead of making it, I squared the current going through the resistor here. So that's a crazy thing to do, but then it actually produced chaotic behavior, which it wouldn't produce if it was just a linear circuit. We'd have to have some nonlinearity in the circuit, I think, to make it do that. But anyway, that's pretty damn impressive, I think, that we can go from that question to something that we can actually compute here. Elsie is asking, can I give some insight into the underlying compute load, infrastructure, scalability, and so on? I wish I could give a better answer to that. It's always very nerve-wracking when you bring online a service like this and you don't know exactly how much usage it's going to get, by who, in what way, and so on. We don't know as much as we would like to know. Let's just say the following. We think that the things that we have provisioned are sufficient, that if it's human users, and that's what we're really, that's what we're setting things up for, human users should be able to happily use this, and as many as want to. Well, let's see whether we have a question here from RBS. It says, let's see, generate random origami 3D objects. Let's see if it has a hope. I have no idea how I would approach this. I think I would start making random polygons, but let's see what it does. Okay, to generate random origami-like 3D objects, you can use the random polyhedron function to create random polyhedra. You customize the properties of polyhedra to simulate origami structures. Here's an example of how to generate a collection of random convex hull polyhedra with transparency and color. Let's see if we believe this. Let's try it. Okay, not terrible. Random colors. Now, I don't really know random origami. Okay, it didn't know how to make these fold out and all that kind of thing, but I'm not sure quite what one wants to do there. But this is, again, I would say I would give this a solid B+ as a start for how to do that. Let's see. Elsie is asking, what are the most important things about the integration of the side chat versus a generic LLM? Oh boy, I don't think a generic LLM could do anything here. I mean, there's so much that depends on, and we can tell this because as we've tuned this with semantic search, and we've been generating lots of effectively training data for our semantic search systems and so on, it's a lot of detail. And this is a pretty well-tuned object that is very different from what you would get with sort of a generic, throw this at a generic LLM. Are there plans to make it work in other languages? Well, yeah, you can type things in languages other than English. I'm sure if I say, let's try this. How about I say, I am going to try this. I'm going to use LLM function. No, I'm going to say LLM synthesize. How would I best do this? Well, I could just do it in the notebook assistant. I could just say translate into, this is very scary because I'm not going to have any idea what it says. Make a collection of randomly colored spheres. Let's give that a try. What is going to happen here? This could get very weird. I haven't tried something like this before. Okay. Well, I have no idea what that says, but let's just try copying it out. And I don't know if I need that. Okay, let's make a new chat. And let's put it in here. Oops. Nope. Go back there. And oh, I see that. Let's copy. Clipboard. Go. New chat. Let me paste that. Okay, very scary. I don't know what this says. This is where you don't let the AI just have control of everything when you have no idea what you even asked it. Okay. So, well, the good news is I can read the Wolfram language code, and I think it will do the right thing. There it is. And hopefully this Japanese says something useful. Let's see. Memes asks, has the assistant had any happy accidents that were particularly useful? A lot of things that were, again, it sort of raises the bar for what you can do on a whim. And if I look at a lot of things that I've invented, discovered over the years, they involve sort of getting to the point where it's easy enough to try it that I actually do it. And I think Notebook Assistant, the point at which you can just do it on a whim has become higher. And so I'm sure if I look at over the last month, the things I've been working on, I just wrote something about the foundations of biological evolution, and I used Notebook Assistant, a bunch of things I did there. And I suspect that what I did, whether any particular discovery I can make, I could point to, yeah, Notebook Assistant suggested. I don't think it did. I think instead it was just like something that I imagined doing. I could now actually do it, and actually did do it, and that wasn't possible before. Okay, let's try. Douglas asks, out of Japanese. Let's try this. Make a graph showing a breakdown of a trig identity, including alternate transforms, expression in each bubble in traditional form. Now, I have no idea what it's going to do here. Let's see if it even understood this. Well, let's try this. This looks a little crazy what it's doing. Let's give it a try. That wasn't good at all. Okay, let's just try again and see whether it generates something better second time around. Otherwise, we might have to help it a bit. I mean, it did figure out that there's a trig identity here, sine 2 theta equals 2 sine. Oh, it's insisting on doing this again. Oh, okay. I wonder why it's make a graph. See, I think that's basically what it's confused about. Well, let's see. Fix that. Let's see whether it can figure out what went wrong. Okay, let me see what this does. Again, not working. Maybe I have to, this specifies the depth of the graph. Why is this not working? You know what? I am curious what happens if I just take that piece. Does that produce anything reasonable? It does. Well, let's get rid of the 2. Just see if that helps. Well, okay. The depth of the graph. So why isn't that working? Let's just try depth 1. Humpty hump. What is happening? Well, let's press this where it says expression graph, and let's go look. Tree graph only down to level n. Well, I think that's right then. it did something reasonable here. So now what is it doing? What is wrong? Is wrong. It says the expressions are displayed in, oh, I see here. Oh, actually, what it did at the beginning was quite sensible. What it says is make an expression graph where it's showing the sine and cosine pieces. You know what? I don't know why that didn't work. I am confused. Let's see. Let's just try here. Maybe. Okay. Okay, so what it did was quite sensible, but for some reason it doesn't. Vertex labels there. Humph. I don't know. I think what it did was quite sensible. Let's just ask it for sort of additional points. Let's just ask it, say, give me some trig identities with examples. Put them in a table. Jing. That's not, I'm not impressed there. Say show that in Wolfram language because it will have generated that way inside. So I don't know why it chose to show it to me that way. Let's try it. Okay. Okay, well, there are the identities. Okay, but how about, well, thank you for saying simplify that, trig expand that. Great. How about well, we could probably ask it. Let's say let's do this. Make a grid of values of sine x. Just to see whether it can, whether it understands. What I'm imagining is that I'm going to get this sort of this table of values. But let's see. Oh no, that was a misunderstanding. It's making, well, let's see what it did. That's a fine thing, but that wasn't what I had in mind. I meant, how do I say it? A table of the numerical values with, let's say, with the input on a blue background, light blue background. Let's see whether that context, even though I'm still being pretty vague and silly about this, let's see whether that context helps it to understand what to do. Okay, that's looking better. Let's try that. Very nice. Okay, that was what I wanted. Good. That was yeah, nice. I mean, it would have been even better if it had labeled the columns, but I can't object. This is a pretty good result. Okay. Toby is asking here a completely unfair question, but I'm going to see what it does with it. Wants to ask, create a slice of pizza using Gaussian curvature. That's a pretty big ask, I would say. For that we need a Star Trek replicator. All right, let's see what this did. Well, actually, that's not completely terrible. Let's see what it did here. The pizza slice it picked was this parametric surface. Now it's computing the Gaussian curvature of that. Plot the pizza slice showing the Gaussian curvature. Hey, that's pretty good. My gosh. I don't know what the create the slice of pizza. I'm not quite sure whether that's, but let's see. let's just say fix that and see whether it figured out what is wrong with that, this rescaling thing, whatever it is. Rescale, where is that? Rescale the Gaussian curvature. I don't know what that looks like. It's unnecessary. I think we don't need Gaussian curvatures as a function of u and v, and it doesn't. Yes, okay, fine. All right, let's give this a try. So it figured out that that rescale was wrong. And now let's say, okay. Run it. I was going to run it over here. And I think the problem here is that the curvature is not quite big enough. Let's just make this Gaussian curvature bigger. Let's just make the curvature. What the heck is that? Let's just try. I think we want to increase the magnitude of the Gaussian curvature so that then or change the, that's what it was trying to do with that rescaling, is it's trying to, oh, there we go. So it's scaling the Gaussian curvature to be in that range in its attempt to make it produce different colors, but it didn't manage to do it. But honestly, I think this is ridiculously impressive that it could get a parametric representation of the pizza slice. It knew how to go and use a function from the function repository to compute Gaussian curvature. It could produce a picture of it. It's, in my opinion, this was quite spectacular, even though it would take a little bit of effort here to go and figure out how to make it so that it has a better color map and so on. Let's see. Mike asks, should I add all my hundreds of notebooks to its semantic base to incorporate into responses? Soon you'll be able to do more of that. Right now, I mentioned the sources button up here, which right now is just dealing with these current notebooks. You will be able to point it to any collection of files and notebooks, and it will summarize those in its own way. In terms of pre-processing that stuff, that will also be possible. That is related to the semantic search and vector database capabilities that we added in version 14.1. Expect in the next few months for those capabilities to become possible. And that will be indeed, actually, as I think about that for myself, that would be something very useful to me, to be able to know about all the function definitions that I've made in all of these existing notebooks, and that should work. Let's see. What about a natural language exploration of a semi-complex dependency graph as one would find in a modern software artifact? Or even just using Wolfram language functions from the repository. I don't know. I mean, let's say, I mean, I'm going to live totally dangerously here, but let's say, make me a parse tree for a piece of C code. I have no idea what this is. Just I'm shot in the dark. What's going to happen here? Let's just see. Okay. To create a parse tree for a piece of C code, you can use the resource function code structure. Here is an example of how to display syntax tree of a simple C program. Okay, well, let's just try it. Grind. What's it doing? It's making me nervous here. Well, I think it will work. In this code structure function, it probably has to, there it is. There it is. With a compound statement, function declaration, et cetera, et cetera, et cetera. Wow. So the answer is yes, I think that will be possible. All right. RB asks, you guys are getting way too ambitious here, but let's give this a try. Create a tool that generates cellular automaton-based snowflake patterns, including a GUI with real-time sliders to adjust parameters like rule number, grid size, and speed. You are asking for something very ambitious, but let's see what it manages to do. Well, I wouldn't have called that a snowflake. It does have grid size. Okay, that's nice. Speed. I wonder what that's doing. Well, it's not a snowflake. let's see, we could try saying, make it a 2D CA growing from a seed in the middle. See whether it does any better. I mean, it gets, I would say it gets points for effort here, although it didn't manage to really do what we wanted, and it didn't do it on a hexagonal grid or anything like that. But let's give this a try. What is it doing here? Splarf. Okay. Let's just tell it, fix that. Just to do it better. I don't know what went wrong there. See, I should read what it's saying, but I'm not reading it. And I find myself not really reading it. I find myself just, just running it and seeing what happens. But if I now start looking at this in a bit more detail, it's yeah, that's not convincing that it's going to be, I see the initial condition, sparse array, okay, of the grid size. Actually, that's not crazy. That looks right. So I don't know what's going wrong here. Oh, I can see what's going wrong. I am going to fix this. Maybe. Let's try putting a, oh gosh, it has continuous action to true, so it's running all the time here. It's a bit scary. I didn't manage that even then. Okay, I thought I was going to fix it there, but I didn't manage to. So we'd have to do a bit more back and forth. Well, let's try. The next question was from Primate. Can it accurately translate phrases into propositional logic expressions and output their truth tables? Well, let's see. Let's say P or Q and R or not P. I think even Wolfram Alpha can do this. So now let's see whether this can do it. It's a little bit not, well, actually, let's say, I think if I type that into Wolfram Alpha, it will just work. And so this might have the sense to try doing that. Okay. Okay. So let's see what it did here. It did logical expand, so it gives true in that case. And if I do this truth table thing, which it also generated for me, it will hopefully. Oh, it didn't work. I don't actually know. I would just use Boolean table for this. Let's see what that does. It's thinking. Again, let's see. It's giving me basically the same thing again. I think I might have to look at, again, I think if I were to help it a bit, I would just use Boolean table here. Oh, let's generate a truth table to confirm this. Yeah, it's going to try and do that again, but I don't know why it's okay. Oh, well, there's Boolean table. Okay, so it can do this, but that was in a sense too easy for it. I mean, if I gave it some word problem, I could try giving it a syllogism and asking it to use find equational proof, for example, to prove the syllogism. We could try that, I suppose. But let's not try that right now. Instead, well, I think that this probably we've run out of time right now, but on Wednesday afternoon, I am signed up to do a new activity that I'm calling Computational X Live, and where it's going to be me plus the notebook assistant plus Wolfram Language doing whatever you guys want me to do in terms of exploring different kinds of areas and seeing how to take any area X and make it computational and see what we can compute in those areas. So that's coming Wednesday afternoon, Computational X Live. Well, so I just want to emphasize that the things I've been showing here, you can get them today, immediately. If you make sure you have version 14.1 of Wolfram language, either in the form of Mathematica or Wolfram 1, any of those things. This is right now available only for the desktop, not for pure online cloud web use. This is a desktop. Works with desktop Wolfram notebooks, but with you can get it now today. I know even when the auto update started today, before we had announced anything, I was pleased to learn that some people had noticed it was there, and we were seeing people starting to subscribe to this at that time. So I encourage people to sign up for this and go computational with much more than you had ever expected before. And I'm as I say, I'm really excited about this as kind of an inflection point for the growth of computational X and computational thinking and computational language. Thanks for joining me here. Look forward to seeing you another time. Bye for now.